All right, 3 chips are tossed. This is what do you expect, the last one that I'm recording. Finally, 3 chips are tossed. The red one has side A and B. That's not the pen. That's not red. The blue one, nope, has a side A, B. The yellow chip, of course I don't have yellow here. Here it goes. The yellow chip has side BC. BC. So in other words, if I get an A on my red chip, I get a B or a C in the yellow chip. If I get a B on my red chip, I get a B or C on my yellow chip. And then for my blue chip, I have A. So now, no matter what, I'm getting an A. Even if there are two of them, it doesn't matter. I'm still getting an A with my blue chip. All right. So before I take a look at this, oh, they're all equally likely, isn't it? Okay. So I have A, B, A, C, A, B, B, A, and B, C, A. So what's greater, the probability of getting exactly 2 B's or probably getting 2 A's? Well, it's pretty obvious. The probability of getting 2 A's is better. It's 1/2 time I'll get 2 A's. Sure, I'll take those red pens. Thank you, ma'am. I love red pens. All right, this is what teachers do when school gets out. They talk about red pens and how much fun they are. All right, I know for fun you do math tests for summer, but I digress. What is the probability of not getting at least 1 B? So not getting at least 1 B. So that means I get no B's, right? Well, this one has no B's. Actually, it's the only one with no B's, so I have a 1/4 chance of that. What is the probability that none of the sides match? So that means I get an A, a B, and a C. Here's BCA. That's the only one, isn't it? That's a bummer. So again, it's 1/4. That none of the sides match. Yeah, so that means I have A, B, C. All right. 2 identical containers contain marbles. We love marbles. Actually, marbles are pretty fun. Container 1 and 2 has 2 white marbles. So I'm going to have container 1. And it has 2 whites and a red. Container 2 has a white and a red. Suppose you select a container random. What is the probability of a white marble? All right. So my chances of selecting a 1 or 2, they're equal, right? So I have a 1/2 chance of getting container 1, a 1/2 chance of getting container 2. Well, what are my odds of getting this W once my hand's in container 1? Well, this is 1 of 3, right? So that means I have a 1/3 chance of the half chance. So really, this is a 1/6 chance overall of me getting this. This is also 1/6, and this is also 1/6. Notice how 1/6 plus 1/6 plus 1/6 equals 1/2. That whole line is going to add up. Well, if my hand is in cup 2, that means I have a 1/2 chance for either one of these. So what is a half of a half? It's a 1/4. And notice 1/4 plus 1/4 is also 1/2. So what are the odds of drawing out a white marble? Well, I add the probabilities of each white. There's 1. Here's my second white. There's my 4th one. So 1/6 plus 1/6 is 2/6, which is 1/3, plus 1/4. That's 12ths. They have to have a common denominator, so this is 4/12ths plus 3/12ths. I just multiplied both the numerator and the denominator by 4, so 7/12ths of getting a white. The probability of a white is 7/12ths. All right, Tua has a spinner game, because a game without a spinner is a game I don't want to play. I know you feel the same way. All right, to play the game, you have to select a spin, and if you make a green, which is yellow and blue, you win! And in A, she spins both spinners. So if I have spinner A has a So this is spinner A. I have a yellow, a blue, an orange, and a red. I'm making an area model. So on this one, this is a little tricky because the yellow is half of it, right? So if I divide the whole thing into 6, I have 1, 2, 3 yellows, don't I? I also have a red, a blue, and an orange. So where are my winners? Winner, 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 chicken dinner. I have 4 out of, my goodness, this is a 4 by 6 grid. So that is 4 out of 24, which is a 1/6 chance of winning. Probably 1 is 1/6. Not very good. Is there a different way to do this? Well, I could do A twice, right? So if I do A twice, I would have yellow, blue, red, and orange. And then my second spinner would also be yellow, blue, red, and orange. Winner, winner, and that's about it. So that's 2 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 6. That is not better. 1/6 is better than 1/8. So then I could try spinner B twice, right? So let's try spinner B twice. So we have the essentially 6 sections. We have yellow, 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 red, blue, and orange. And again, we have yellow, 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 orange, blue, red. Yellow and blue, yellow and blue, yellow and blue, blue and yellow, blue and yellow, blue and yellow. So we have 6 winners out of 6 times 6 is 36, which is equal to 1/6. That is the same odd of winning. So no, there isn't a better way of doing it. I could do spinner B twice, or I could do spinner A and spinner B. Last page. I'm so excited to go home. I feel like everyone else has started summer and I haven't. I'm sitting at school on detention. I'm sure some of you can relate to that. It is no fun. A school has exactly 3 children. What is the probability that they have a girl, a boy, and a girl in that order? 3 children. So I can either have a boy or a girl. There are no other choices. That's my first child. If my first child's a boy, I can have a boy or a girl. If my first child's a girl, I can have a boy or a girl. Third child can either be a boy or a girl. If my second child's a boy, boy or girl. All right, so then what are the odds? Probably that I have a boy, a girl, and a girl in that order. That's a girl, a boy, and a girl. That's 1 out of 8. Probability of girl, boy, girl. Exactly 2 boys. So I have highlighter. There we go. Boy, boy, girl. Boy, girl, boy. Girl, boy, boy. So that is 3 out of 8. All girls? Well, to get all girls, I only have a 1/8 chance of that, because that is right here, not including that one. You are offered the following choices for babysitting. Why can't they just give me just 1 flat or normal rate per hour? That would make a lot more sense. $6 per job, or the amount of money you get by drawing 2 bills from a bag containing 1 10 and 4 ones. You do not replace the first bill after you draw. So how much money would you expect to average per hour over the long run if you selected the draw-out method? So let's figure this out. So I have a 10, 1, a 1, a 1, and 4 ones, of course. A 10, a 1, a 1, a 1, and a 1. So again, I'm making an area model. I can't get 2 10s, and these are the same bills, right? So here's 11, 11, 11, 11, 11, 11, 11. Because all of them contain a 10 and a 1. All right, so then, unfortunately, we have some 2s as well. So I have 1, 2, 3, 4, 5, 6, 7, 8 $11 scenarios, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 times. So I add them together. So that's a total of $112. But how many babysitting sessions was that? Well, that was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 different scenarios. So if I make $112 out of 20 sessions, that's an average of $5.6 per session. Would I choose that? No! I'd rather just take the $6 and be done with it. In the long run, I'd earn a little bit more money that way. That family's trying to shortchange me 40 cents per babysitting session. Cheapskates.